We now add the next layer to the word simplify for radicals. Okay, so you're going to get questions that have one word in the instruction that say simplify. And simplify for radicals, we've already learned that it means, number one, we have to write our radicals as mixed radicals. We've already learned, number two, that if you have like radicals, it's not simplified unless you combine them. And now we're going to learn number three, which radicals are not simplified unless you rationalize the denominator. So what does that mean? Okay. We have fractions. And if you have a square root on the bottom of your fraction, we would say the bottom of our fraction, our denominator, is an irrational number. The concept of rationalizing your denominator says we do not want an irrational number in our denominator. So I asked myself, well, what could I multiply square root of 2 by to get rid of the square root? The only thing that would work nicely is another square root of 2. But if I multiply the bottom of the fraction by square root of 2, that changes the value of that fraction. But if I also multiply the top by the square root of 2, technically what I'm multiplying by is 1. And multiplying by 1 doesn't change what it equals, just changes what it looks like. So in this case, root 2 times root 2 is root 4, and square root of 4 is just 2. And on the top, 1 times root 2 would be root 2. And now I have a rational number in the denominator, and so I've rationalized the denominator. You had to do multiplying by 1 with fractions. If you wanted a common denominator, sometimes you have to change the fraction. Here it has 3/5. 3/5 is the same as 12/20. It just looks different. The numbers are different, but the value is the same. Root 2 over 2 is the same as 1 over root 2. It just looks different. Now, historically, so a little bit of the history behind rationalizing the denominator and where this came to be. Because you're like, what difference does it make if I have 1 over root 2 and root 2 over 2? And for our day and age, almost nothing. I'm sorry. You have calculators. Your calculator can do 1 over root 2 just as well as it can do root 2 divided by 2. It's equal for a calculator. Both are not hard for a calculator or a computer. But 100 years ago, when it was asked to do this by hand, this calculation by hand might take you 10 minutes. This one, 25 minutes. So if you could take 30 seconds to change from 25 minutes to 10 minutes, you would do that because it made your life a lot easier. So the idea of rationalizing the denominator to getting the denominator an integer is steeped in when you used to have to do this by hand, calculations by hand. This would be a lot faster. Square roots by hand, oh. If you want, sometime I'll show you that. Not today. But it is a crazy technique. So if you want to highlight, this is called rationalizing the denominator. And now when we have the word simplify, we have to rationalize the denominator as well. Just the definition of rationalizing the denominator. So here, simplify. We have to look at all of our square roots and go, do we have any like terms? Do we have any square roots that we could write as a mixed radical in lower terms? And do we have a square root in our denominator? Because that's not allowed. In this case, yes, we have a square root in our denominator. How do I get rid of that square root in that denominator? I would need to multiply the bottom of the fraction by the square root of 7. If I do that, I would need to multiply the top of my fraction by a square root of 7. So I'm multiplying by 1 I'm not changing the value of the fraction, I'm just changing the way that it looks. On the top, I would have to distribute 5 root 7 times root 7 would be 5 root 49. 3 times root 7. And root 7 times root 7, okay? Maybe now you're already comfortable with just saying 7. You okay that I didn't go to root 49 first and then make it 7? Okay? And so on the top, I still can simplify the square root of 49 because it's 7. 7 times 5 is 35 plus 3 root 7 over 7. And each time you write a new line, you have to go through all 3 of those steps. Do I have any radicals that I could write as mixed radicals in lowest term? The only radical I have is root 7. Is it in lowest terms? Yes. 2, do I have any like radicals or like terms that I can combine? No. Is the bottom of my fraction a square root? No. So after spending 5 minutes looking at this, you can say, oh good, I'm done. Didn't take quite 5 minutes. But it's that process. You have to, when you're asked to simplify, you have to go through all 3 of those things and make sure all of them are done. For part B, we have a square root of 18 on the bottom. That's not allowed. So I could start by multiplying the top and bottom by the square root of 18. Ooh, I can tell you're not going to like this one. Ooh. Okay, let's stretch a little bit, get our brains ready. So far, not a problem. Root 18 times root 18, can you see that's going to be 18? If I distribute on the top, I'm going to get 6 root 36 minus 4 root 54. Is there anything I can simplify? What's the square root of 36? 6. 6 times 6, that will be 36. Minus, can I simplify the square root of 54? Then that's not simplifying. Simplifying means writing as a mixed radical in lowest terms. So is this a mixed radical in lowest terms? No, what can you break up 54? 9 times 6. So if 54 is 9 times 6, and the square root of 9 is 3, 3 times 4 will be negative 12 root 6. Okay. Here's the intermediate step if you missed that. Does that make sense with the intermediate steps there? So you can write as many of those steps down as you want. And this is still all over 18. Are we done simplifying our radicals? Do we have a radical that isn't in mixed, as a mixed radical in lowest terms? That's a mixed radical in lowest terms. Do we have any like terms or like radicals? No. Do we have a radical in our denominator? No. So as far as simplifying radicals, we're done. But the word simplify also deals with fractions. And when you have a fraction, you need to have it in lowest terms. And this fraction itself isn't in lowest terms. And this is why you guys aren't going to like this one. Because I can simplify the fraction here. And here you are going to be tempted. Math is full of temptations. You are going to be tempted to go, oh, 36 divided by 18 is 2. I'll just make that a 2 and I'm done. Yeah, and that's like bad math. Why? Because that 18 is dividing everything. In grade 9, you did a unit on dividing binomials by monomials. And so this 18 is dividing both of these. What does that mean? Well, here we go. Two ways you could go about this. My favorite way is to use factoring. I look on the top of my fraction, which has two terms, and I ask myself, is there something I could factor out of 36 and 12? Is there a number that's both in 36 and 12? 6? Any higher ones? 12. So if I factor out 12, I'd be left with 3 minus root 6 all over 18. And now that this is multiplication right here, mathematically you're allowed to simplify the fraction. While it's adding and subtracting, this is grouped together as one term, and we can't simplify it. How do you simplify 12 over 18? Is there a number that divides both of them? 6. And so you would be left with 2 over 3. And that's our final answer, simplified. I'm telling you, the word simplify in math, if I wrote out everything that the word simplify in math means, it would probably take about 2 pages of explanations. It's the most complex instruction that a math question can have. And it's the word simplify. It should be easy, but it's not. Question. The answer, do they have the answer as 6 minus 2 root 6 over 3? Yeah. So they've distributed after they simplified. And you get the same thing. Okay? If you left it factored or distributed it after, technically having the brackets on the 2 pages is not in the simplified. Simplified would mean no brackets are left. Expanded completely. Okay, we won't do the last example. Your questions for this one are 6, 9, 13I and 13II. But not I. Okay? And 14.